So standard deviation is a measure of the dispersion or variation in a distribution equal to the square root of variance or the arithmetic mean of squares of deviations from the arithmetic mean. So the variance can be given by variance is equal to sigma xi minus xav whole square by n. Sigma is equal to square root of the variance is equal to square root of sigma xi minus xav whole square by n. In simple terms, it shows how much variation there is from the average. It may be thought of as the average difference from the mean of distribution, how far data points are away from the mean. A low standard deviation indicates that data points tend to be very close to the mean, whereas high standard deviation indicates that the data is spread out over a large range of values. Properties are sigma greater than or equal to 0. Sigma is equal to 0 only if all elements in a set is equal. Let standard deviation of xi be sigma and mean of the set be mu. Then standard deviation of xi by a is sigma dash is equal to sigma by a. Standard deviation of xi plus a is sigma dash is equal to sigma. Decrease or increase in all elements of a set by a constant value does not decrease or increase standard deviation of the set. If a new element y is added to xi set and standard deviation of a new set xi comma y is sigma dash, then sigma dash minus sigma if mod y minus mu greater than sigma. Sigma dash is equal to sigma if mod y minus mu is equal to sigma. Sigma dash less than sigma if mod y minus mu less than sigma. Sigma dash is the lowest if y is equal to mu. Let us look at some examples. This is set 67, 32, 76, 35, 101, 45, 24, 37. If we create a new set that consists of all elements of the initial set but decreased by 17%, what is the change in the standard deviation? We don't need to calculate, as we know rule that decrease in all elements of a set by a constant percentage will decrease standard deviation of the set by the same percentage. So the decrease in standard deviation is 17%. Statement. So A should be sufficient. And another example, standard deviation of set 23, 31, 76, 45, 16, 55, 54, 36 is 18.3. How many elements are one standard deviation above the mean? Let's find the mean. Mu would be equal to 23 plus 31 plus 76 plus 45 plus 16 plus 55 plus 54 plus 36 by 8, which is 42. We need to count all numbers greater than 42 plus 18.3 is equal to 60.3. It is one number minus 76. The answer is 1. This is set A of 19 integers with mean 4 and standard deviation of 3. Now we form a new set B by adding 2 more elements to the set A. What 2 elements will decrease the standard deviation the most? The closer to the mean, the greater decrease in standard deviation. D has 4, equal our mean, and 5, differs from mean only by 1. All other options have larger deviation from mean. Normal distribution. This is a more advanced concept that you will never see in GMAT, but understanding statistic properties of standard deviation can help you to be more confident about simple properties stated above. In probability theory and statistics, the normal distribution or Gaussian distribution is a continuous probability distribution that describes data that cluster around a mean or average. Majority of statistical data can be characterized by normal distribution. Mu minus sigma less than x less than mu plus sigma covers 68% of data. Mu minus 2 sigma less than x less than mu plus 2 sigma covers 95% of data. Mu minus 3 sigma less than x less than mu plus 3 sigma covers 99% of data.